So hello and welcome back. Today we will talk about making a state machine, which is a way of designing a task for your robot. Our robot is going to have three states. The first state is going to be random wander. The second state is going to be avoid obstacle. And the third state is going to be track light. So the way this works is that as long as there's no light in the environment that the robot needs to track and there's no obstacles for it to avoid because safety first always, then the robot should just randomly wander around the environment. If there is light, it switches to the track light state. And if there's an obstacle, it switches to the avoid obstacle state. And if there's no obstacle and no lights, it goes back to random wander. We're going to design this architecture in hardware and software by simulating the states with LEDs, green for random wander, blue for track light, red for avoid obstacle. Then once we're sure that's working, we're going to build the hardware in the system and show that we can write the code to make our robot do this. Note that we could write this as a state machine, pseudocode, or as a subsumption architecture. So let's see what the state machine looks like as a subsumption architecture. So here's what our state machine would look like as a subsumption architecture, where we now write it as these layers, where our three primitives are sense, plan, and act. So first we sense. We're going to do that with either a photoresistor or with a sonar. And then we plan, where our plan is either random wander, no obstacles, no light, track light if the photoresistor senses light, or first priority is always avoid obstacle if the sonar senses an obstacle. And we can inhibit and subsume each of these layers based upon our priority in the hierarchy. And from there we act, which is where we now command the robot to move based upon the motor actuators and the wheels. Let's take a look.